Hello and welcome to this SeaSharp Eurocode9 tutorial episode. This episode will be about defining and running the analysis, the Eurocode9 code check analysis. And the first thing I will do is to define a transformation. And reason for doing this I will explain in a few seconds. And secondly, I will define an environment location. The only thing actually employed here is the gravity constant. This is visualized, but I don't need to visualize it. And then we go into the Eurocode9 analysis folder and we say we want to define a new Eurocode9 code check. And on the first row here we define a transformation. And the reason for doing this is that if you are running a super element analysis in SeaSharp, the geometry, the T file, may be transformed from its original position and to the position in the results file from SeaSharp. So if you have such a transformation, you can define it here to move the structure into the correct position. And here we specify the result file from the finite element program. So I just click here and I select this result file. Then it was the environment data. And then you can specify two different code versions, either with amendment A1 or with both amendment A1 and A2 to the Eurocode 99 standard. And you specify this unit of the stresses and the forces on the SeaSharp file, the result file from the finite element program. And when you're code checking the beams, the program does not only check the endpoints of the beam, but it goes through the entire beam with the delta distance that you specify here. And here it's 1 meter. And here you can say that you want to check torsion or not. And for the plate fields, you can say that you only want to check shear. And you can, for the combination factors in the beam checking, there is actually an option to choose more or less conservative exponents. And the default here is to use the most conservative exponents. And then you have to select your beams. So here I will just go in and select some beams. Let's not take too many here because it will take some time to run through. And then you have to select the plate fields. In this case I don't have any plate fields. And you have to select the load combinations that you want to investigate. So now maybe we'll look at these 4 load combinations. And then we say OK. And now the beams that we selected, they are visualized here. And when we have run the analysis through, you can color code these, or you can color these beams according to the utilization level. So now I will just first save here and then I will try to run this through. Execute the code check analysis, 4 threads. And now I start it. And the first thing the program now does is that it computes the buckling capacities of these beams. And it then uses a non-linear finite element solver to compute the buckling capacity. And in this process, it needs to check several directions of imperfections, as well as a positive and a negative direction of the applied bending moment to find a critical moment for buckling capacities. So this process, all in all, can take quite some time. So as we see now, it has completed 10 out of 14 beams, and it is still computing buckling capacities. And we shall see now if it can finish this in a reasonable time. So now it has completed, and it took actually 120 seconds to compute the buckling capacities for these beams. And then it took almost no time at all to actually execute the code check once the capacities have been completed. Then I can just take down this dialog. And here we see that we have got color coding on the beams, and to see the value corresponding to the colors, I click on the utilization color palette, and here you can see that these green beams are maybe 0.6, 0.7, something like that. And if you go into the draw style of this analysis, you can see that you can visualize the total utilization, which will be the highest of the buckling and the yield check. And you can also show it with deformed shape. Let's try that. Sorry, the load combination is this one, I guess. Then it needs to read some data from the SeaSharp file. And this takes a bit of time because the SeaSharp file is gigabyte or 2. So we have to wait for this. And now the deformations are not very large, so we will try to increase the scaling factor. There we got some deformations, beams. Okay, and you can just show the yield utilization. And you can just show the buckling utilization. And you can also, if this was a plate field, you could show the stresses for the governing load combination, the burst load combination. And here, first we will go into report settings, and we will just specify a directory somewhere. And then we select write report. And then we get this HTML report, and we can go down and have a look at this. And here first we get a table of the yield utilizations, and it's sorted according to the magnitude of the utilization. So the highest utilization will come first, and the utilization for tension, compression, bending, shear, torsion, bending, and shear, bending, and axial force. And then we have a table for the buckling utilizations, and again it is sorted, and you can see the values for the different utilizations. And then further down we have very detailed results for each beam. So at the most critical load combination, giving the highest utilization, this was the input that the program gave, with all the section parameters and forces and so forth. So then the user can go through this and try to quality check the results and see that everything is okay. So this is listed for all the beams actually. And that completes this summary of the analysis execution. Thank you for watching.